Okay, so last time we worked on the first part of the confidence interval. That is, we did the confidence interval for mean, right? When the population standard deviation was given. Now, today we are looking at the second part, that is confidence interval for mean when the population standard deviation is not given. That is the second one. And the third one we'll be doing is the confidence interval for proportion. Okay, so we are looking at two different types of confidence interval today. So let's begin with the second one, confidence interval for mean when the population standard deviation is unknown. So the concept is exactly the same. Whenever we want to construct a confidence interval, we'll have the point estimate in the middle. So same thing here. Here also we'll have the confidence interval with the point estimate in the middle. Because we are looking for the confidence interval for mean, we have sample mean in the middle, right? And then to find the lower and upper boundary, we subtract the margin of error from the point estimate. And for the upper one, we add. For the lower boundary, we subtract the margin of error. For the upper boundary, we add the margin of error. So this diagram shows the actual confidence interval, okay? Confidence interval. But here, when we find the margin of error, we have to be a little bit careful there. In order to find the margin of error in this case, formula for margin of error will be a little bit different. Margin of error, if you remember from the previous part, margin of error is equal to the critical value, right? Critical value. But here the critical value will be a little bit different because the population standard deviation is unknown. The sampling distribution will not be the normal distribution. Instead, it is going to be something called t distribution. Okay, the distribution is called the t distribution. And when we talk about t distribution, we also talk about an important feature called the degrees of freedom. And the degrees of freedom will be n-1. So t distribution, it looks very similar to the normal distribution, okay? But it's not exactly the normal distribution. When the sample size is really large, then the t distribution will be approximately same as the normal distribution. And when we are talking about the t distribution, we don't talk about mean and standard deviation. Here we'll not talk about mean and standard deviation. Okay, we'll not talk about mean and standard deviation. Instead, we need the degrees of freedom. And what is degrees of freedom? That is the sample size minus 1. Okay, whatever sample size is given, you subtract 1. That is called the degrees of freedom. So we'll make use of degrees of freedom when we want to handle the t distribution. When we work on normal distribution, we need mean and standard deviation. When we work on t distribution, we need degrees of freedom. So because the population standard deviation is unknown, the distribution will be a t distribution with n-1 degrees of freedom. That's why the margin of error will be given by this formula. In place of critical value, we'll have t critical, okay, t sub c. T critical multiplied with population standard deviation is unknown, but we'll have the sample standard deviation. So it will be s over the square root of n. So margin of error is equal to t critical times s over the square root of n. Okay. And then in order to find the t critical, the process is very similar. Our calculator will help you. So let's try to draw a t distribution here just for a quick reference. So the t distribution, it looks like the normal distribution, okay? But this is t distribution, because the population standard deviation is unknown. And when you talk about t distribution, we are talking about t distribution with certain degrees of freedom, and the degrees of freedom is always n minus 1. So that diagram represents the T distribution with n minus 1 degrees of freedom. And because we are constructing the confidence interval, we'll have the idea about the middle area in the middle of this distribution, right? If the confidence level is 90%, area in the middle is 0.9. If the confidence interval is 95%, then the area in the middle is 0.95. So whatever it may be, you will have that area in the middle. So I'm going to represent that area in the middle. Let's say that area is C. C is the area in the middle. And as we discussed in the previous class, the remaining area is denoted by alpha, and that is divided into two parts in the tails, right? So in each tail, you'll have the area equal to alpha over 2. In each tail, you'll have the area equal to alpha over 2. C is the confidence label. One more time. C is the confidence label, and alpha is the significance label. C plus alpha is always 1, just like in the first part. Now, the values that goes along the x-axis here, this value where I'm showing with the dot there, that is the T critical. Okay, that is T critical. And the value on the other side, that is equal to T critical, but opposite. So negative T critical. And we need to know how we can find that T critical using our calculator. That's very important. So in order to find T critical, let me show you here. So from this diagram, if you want to find T critical, in case of normal distribution, if we want to find the values along the x-axis, we used to use inverse normal, right? Just like that, here we'll use inverse T. Okay, we'll use inverse T. Inverse T. And then what we need is very similar process. We need the area to the left of T critical. Okay, we need area to the left of T critical. So inverse T, then we need area to the left, and then we write the degrees of freedom. We don't need mean and standard deviation here. So we'll use this information, or we'll use T inverse or inverse T in our calculator to determine the critical value along the x-axis. And then after we use this value, we get the T critical information about the sample standard deviation, and sample size will be given. So that's how you will be able to find the margin of error. Then by subtracting the margin of error and adding the margin of error, you'll be able to get the lower and upper boundary for the confidence interval, and we can easily get that confidence interval. Okay. And if you want to see where that inverse T is in your calculator, you go to the same place, second vars, right? Press it and check it. Check in your calculator. So when you go to second, 1 second. Second, vars, and the number 4. That is correct. Very good. Second vars number 4. Then you'll see the field for putting your area and degrees of freedom, and that area is area to the left. So we don't have the concrete example right now to plug in the values. So we're going to take an example so that you'll be able to use that in your calculator and get the value. So let's move on to example. Okay, here is our example. Let's see, what is this talking about? There are a lot of words, so we are going to read it first and find out. Okay, Karen wants to advertise how many chocolate chips are in each big chip cookie at her bakery. Okay, So she wants to advertise about how many chocolate chips are in each big chip cookie at her bakery. And what she is doing is she randomly select a sample of 75 cookies and find that the number of chocolate chip per cookie in the sample has a mean of 16.5. So when she was analyzing that sample of 75 cookies, she found that the mean number is 16.5 and the standard deviation is 3.5. Remember, here this standard deviation is about the sample. Do you see that? It is about the sample. So if you look at that sentence carefully, you can see she randomly selects a sample of 75 cookies and finds that the number of chocolate chips per cookie in a sample has a mean of 16.5 and a standard 3.5, standard deviation 3.5. So 75 cookies, that is the sample, right? Sample size N. 16.5 is the sample mean. And then 3.4 is the sample standard deviation. Okay, so standard deviation is given, but not the population standard deviation. Instead, they have given the sample standard deviation. Now, the question is, what is the 90% confidence interval for the number of chocolate chips per cookie for big chip cookies? Okay. So basically what we're trying to do is we want to construct a 90% confidence interval, right? That's what we want to do. And you know how we construct the confidence interval. We need the point estimate in the middle. So let me draw this line here and then put the point estimate in the middle. So what is the point estimate here? Right, that's the sample mean, which is 16.5. Very good. Sample mean, which is 16.5. Next thing is we have to find the margin of error, then subtract the margin of error to get the lower boundary, and add that margin of error to get the upper boundary. But what we know here is the sample standard deviation instead of population standard deviation. So the distribution must be the t distribution, right? In this case, if we want to find the margin of error, we can write this here. Margin of error is equal to t critical multiplied to s over square root of n. Right. So when you see the sample standard deviation, then the distribution will be t distribution. So we use the t critical times the sample standard deviation over square root of n. Yes. So if I want to use this formula now, I have the sample standard deviation, which is 3.4. I know the sample size, that is 75, but we don't have t critical, right? So first of all, we are going to draw that distribution and find that t critical. So let's draw the t distribution this time. Diagrams look very similar, right? Nothing different there. So this is t distribution. T distribution with, what is the degrees of freedom in this case? 74. The degrees of freedom, because the sample size is 75, degrees of freedom is 1 less than that, right? 75 minus 1. In fact, how much is it? 74. With 74 degrees of freedom. Along the x-axis, you have the t values. So this is the t distribution with 74 degrees of freedom. One more time, 74, because the sample size is 75 and the degrees of freedom is 1 less than that, right? 75 minus 1, 74. And here we are constructing 90% confidence interval. So area that goes in the middle is 90%. So we'll show that 90% area in the middle. Let's show that area. 90% area in the middle. So this area must be 0.90. Okay. So if the area in the middle is 90%, how much area is the remaining area? 10% area divided into two parts. So 5% each, right? 5% on each tail. So 0.05. 0.05. And the value that goes here in the x-axis is your T critical. And we want to find that T critical. And as we know, T critical is given by this. T critical is equal to inverse T in your calculator. And then area to the left of T critical. Everybody look at the board. Here is T critical. So area on the left is 90% plus 5%. That is a 95%, right? 95% area is on the left. So 0.95, 95%. And we don't need mean and standard deviation here. Instead, we use the degrees of freedom, which is 74, right? 74. Now, please go to second verse, number 4, put the values and tell me what you get for T critical. Everybody. Yes, how much? 1.6657. That is correct. Make sure everybody plug in the values, okay? And then check it. It must be 1.6657. Let me write it here. 1.6657. So go to second, and then vars, and number 4. Did you find it? Yeah. Okay, good. Okay, I'll wait here for 30 more seconds so that all of you will be done with your calculator. One more time, in order to locate inverse T in your calculator, go to second, vars, and then number 4. Okay, now let's use that value and calculate our margin of error. So we are going to plug in the value of T critical into the equation for margin of error. So let's do that. So T critical is 1.6657, then multiplied with standard deviation of the sample, 3.4, and divide that by square root of sample size, that is the square root of 75. And simplify that and tell me what you'll get for margin of error. 1.6657 times 3.4 over the square root of 75. How much you got? 0. Okay, 0.6540. Because the point estimate, which goes in the middle of this confidence interval, is given up to 1 decimal place, as you can see, 16.5. I can also round this to 1 decimal place, okay? So instead of writing 0.6540, I can write that as 0.7, right? When I round to 1 decimal place, 0.7. We are rounding this to 1 decimal place because you know that margin of error, we are going to add and subtract to the point estimate, right? And the point estimate is given to 1 decimal place. So we also want to do that calculation to 1 decimal place here. Okay, so let's find the lower boundary now. Lower boundary for confidence interval. Now, lower boundary for confidence interval. As you can see, it is the mean or the point estimate minus the margin of error. So the mean is 16.5 minus 0.7. How much is that? 15 point how much? Yeah, subtract. Yeah, you're subtracting. 15.8. Okay. 15.8. Now let's find the upper boundary. Upper boundary for confidence interval is 16.5 plus 0.7. What do you get? 17.2. Okay. So the lower boundary we got 15.8. Upper boundary we got 17.2. So we can write our confidence interval. Hence, 90% confidence interval for mean is, it is from 15.8 up to 17.2. Right? 15.28 up to 17.2. So you can write it like this using the interval, or as I show you in the previous class, you can also write in other two different forms, right? So the other two different forms are, you can write as inequality, right? The next one is you can write this as inequality, or this is same as, you can write like this, 15.8 less than the mean, which is less than 17.2. You can write like this, or the last way is you can write 16.5, then plus or minus the margin of error, which was 0.7. It really depends on how the question is asked in your mastery exercise. If in the mastery exercise, you have to enter the answer inside the interval, you go with the first form, right? If you see the interval, I mean the inequality form, then you go with the second one. And if you see plus or minus, you go with the third one. But in the quiz or the test or in your final exam, right? If you write in any of these three forms, I'm okay with that. Okay, whichever is easy for you, because I understand all three of them. So you just write in any of the form you want. So you should know the meaning of that. Okay, you should know the meaning of this confidence interval. The meaning here is, with 90% confidence, we can say that the average number of chocolate chips per cookie is between 15.8 up to 17.2. Make sense? So that is the meaning of that. And we can say that with 90% confidence. So when you pick a cookie at random, then probability that you get the chocolate chip between these two numbers is 0.9. And it can be less than or more than these two numbers, will be the remaining 10%. Okay, any question on this example? So you can clearly see that the concept is exactly the same, right? We have to find the point estimate in the middle, and then we need the margin of error. But while calculating the margin of error, the formula is slightly different here because the population standard deviation is not given. Since the sample standard deviation is given, the sampling distribution will follow the t distribution, and formula for margin of error, as you can see, is t critical times the sample standard deviation over the square root of n. Remember, when you are doing your quiz or the test, you have to read the question very carefully. Figure out whether the population standard deviation is given or sample standard deviation is given, and based on that, use the formula accordingly. Okay? So you should know which distribution to use. If the population standard deviation is given, you use the standard normal distribution. If the sample standard deviation is given instead of population standard deviation, then you use the t distribution. Okay, now we move on to the third type of confidence interval, and this one is the confidence interval for proportion. One more time, the concept is exactly the same again. Okay, concept is exactly the same. In order to construct the confidence interval, we start with the point estimate in the middle, because here we are talking about the proportion. The value that goes in the middle will be sample proportion p hat. Okay, it will be the sample proportion p hat. And you know the meaning of the proportion. That is the part of the sample, right? Not everyone in the sample, but certain portion of the sample. It can be expressed as a percentage. If the percentage is given, you change to decimal and write it there. Okay. If the values are given, say, for example, the sample size is 30, and then 15 of them is the proportion, then it will be 15 over 30, which will be 0.5 again, right? So that is your p hat. And once you know p hat, what you do is we find the lower boundary by subtracting the margin of error. We find the upper boundary by adding the margin of error. Right? P hat minus margin of error will be the lower boundary. P hat plus margin of error will be the upper boundary. And remember, in order to find the margin of error here, we have the similar formula. Margin of error is equal to, we use the critical value. If you remember the confidence interval first type or the second type, we have the critical value, right? In the first one, we studied about the confidence interval for mean when the population standard deviation was given. It was standard normal distribution. The second one was confidence interval for mean when the population standard deviation was not given. So the critical value was T critical, right? But for proportion, it is always standard normal distribution. So this is also going to be Z critical. Okay, standard normal distribution, Z critical, then multiply that by the standard error will be P hat times Q hat over N. Although I've written those two formulas slightly differently over there. As you can see, the first formula here where I'm pointing with my mouse, right? I use Z alpha over 2 because Z critical and Z alpha over 2, they are the same. So here I use Z critical. And then inside the square root, I use P hat times 1 minus P hat. But you know that 1 minus P hat is Q hat. So we can also write the formula safely like that in a compact form, right? Margin of error is equal to Z critical multiplied to square root of P hat Q hat over N. Okay, so you can box that formula if you want. If you just want to use that. And similarly, just like in the first, part of our confidence interval, we also learn how to find the sample size. If I want to estimate the sample size, how do we estimate? Here is the formula for that. I can also rewrite this formula by a little bit of simplification. So N is equal to, as you can see here, we have a P hat. I can write P hat as it is. And then we have 1 minus P hat. 1 minus P hat is Q hat. Okay, and then multiply to Z sub alpha over 2 is same as Z critical over the margin of error squared. So that is just the little bit simplification. Same formula written slightly differently. So if I want to find the sample size to construct certain confidence interval, right, we'll use that formula. And remember, because you are calculating the sample size here, your rounding is just like in the first part we did last time. That is, you have to round it up. Okay, you have to always round it up. So you can write your rounding key there, and it's always rounded up. If you get a decimal value, then you have to round it up. Always. If you get 20.1, it is 21. If you get 20.2, and also it is 21. If you get 20.5, 21, 20.6, 21, right? Always round it to the next whole number, round it up. So probably you have already noticed that the concept is again similar, right? Very similar concept. We need the point estimate in the middle, and then we have to find the margin of error, add and subtract the margin of error to get those boundaries. Let's take an example. Okay, here we have the example. You can see that the question looked really short, but let's find out how we can do it. I hope it is just that easy also. So what they are saying, out of 200 people sampled, we are talking about a sample of 200 people, 162 had kids. Out of 200, 162 of them have kids, right? So based on this, construct a 99% confidence interval for the true population proportion of people with kids. So when you're talking about a small group of 200 people, okay, maybe these are 200 employee at certain branch of a company, right? And then they have 162 had kids. So from there, you know the proportion of the people with the kids. That means using that information, what can you say about the entire company, right? We are just talking about one branch. So if we want to talk about the whole company, what is the proportion of the people with kids in that company? So the question is something similar to that. Okay. So first of all, when we say this is sample, you can see 200 is the sample. We are talking about sample. Out of 200 people sampled, n is equal to 200. 162, how many? 162 had kids. 162 had kids, right? So that means, what is the proportion here? What is the sample proportion? P hat is equal to 162 out of 200. And if you divide that, what is that equal to? 0.81. Is that what you said? 0.81? Okay, 0.81. 0.81. So that is telling us that 81% have kids, right? In that sample, 81% have kids. So how many of them don't have kids? What is Q hat then? 0.19, because 81% plus 19% will make 100%. 81% have kids, 19% they don't have kids. We want to construct, say that again. Okay, yeah. Usually small population, always right, yeah. Yeah, you're right. Okay, now let's try to construct the confidence interval. And when you try to construct the confidence interval, you know what goes in the middle, right? The point estimate, that is P hat. P hat goes in the middle, and that value is 0.81. We want to find the lower boundary and upper boundary, and you know the lower boundary is P hat minus margin of error. Upper hand boundary will be P hat plus margin of error. And remember, because we are talking about margin of error, the distribution is going to be standard normal distribution, right? All we can do is we can use that formula and find the margin of error. So in next step, we'll try to find the margin of error if possible. Now the margin of error is equal to Z critical multiplied to the square root of P hat Q hat over N. But you can see we have P hat, we have Q hat. P hat is 0.81, Q hat is 0.19, N sample size is 200, but we don't have Z critical. So next thing we want to do is we want to sketch the standard normal distribution and find that Z hat. So let's do that. Let's sketch the standard normal distribution like that. So this is our standard normal distribution. That's a normal distribution with mean 0, standard deviation 1, Z values along the x-axis. And then we have, because we are constructing 99% confidence interval here, we have 99% area in the middle. We want to be 99% conform here. Okay. So you can see 99% area is in the middle, right? So the remaining area is 1%. 1% area is divided into two parts. That means we have 0.5% area on each tail. So we'll label that half% area, which is 0.005, half%. 0.005, half% means half divided by 100, right? Half divided by 100 is 0.005. Or if you add these three numbers now, it will be exactly equal to 1 because the total area under the normal curve is always 1. Now this value that goes along the x-axis, let me show you by dot, that is Z critical. And we want to find the Z critical because once we know Z critical, we can plug in here and find that margin of error. Okay. Z critical is the value along the x-axis. So in a normal distribution, look at the board. In a normal distribution, if you want to find the value along the x-axis, do you use normal CDF or inverse normal? Inverse normal. Okay, we use that inverse normal. And then area to the left of Z critical. If you look at the diagram here, you can see area to the right is 0.5%. That means you have 99.5% area on the left, right? So which is 0.995. 0.995, mean is 0 and standard deviation is 1. And if you type that in your calculator, tell me what you'll get. Inverse normal, 0.995, mean 0, standard deviation 1. What do we get? Very good, 0.5758. 2 point, right? You said 2 point, I wrote 0 point. That is my bad. 2 point. Yeah, 2.5758, perfect. Very good. We are going 99%. So yeah, 2.5758 is your Z critical. Now, next step is to plug in Z critical into the equation for margin of error and calculate that margin of error. So let's do that. Let's plug in the values. So margin of error will be equal to 2.5758 times the square root of P hat is 0.81, Q hat is 0.19, over N is 200. When you type here, make sure you type it carefully, because inside the square root, you are typing 0.81 times 0.19 over 200. That is inside the square root. So everybody, please type that. And let's find out what you will get. 2.5758 times the square root of 0.81 times 0.19 over 200. Did you get it already? That's correct. Yeah. 0.1434. No, I asked you to type it again. Yeah, multiplication. Yes. 2.5758 times. Did you do addition or something else? Subtraction. Okay. It's multiplication in the middle. Yeah, 0.71. 0.715 if you round it to 3 decimal. But in this one, now let's see. Everybody look at the screen. If you look at our confidence interval here, the point estimate is 0.81, right? It is up to 2 decimal places. Do you see that? 0.81. So when you find the margin of error, also round it to 2 decimal places. So it will be 0.07. Okay. 0.07. Are we good so far? Yes? Okay. So what we'll do next is we'll add and subtract those margin of error and find the boundaries. So the lower boundary for confidence interval is equal to 0.81 minus 0.07. What is that equal to? 0. I didn't hear. 74, 0.74. Is that what you said? Good. Okay. 0.74. So the lower boundary, 0.74. Upper boundary, let's find upper boundary for confidence interval is 0.81 plus 0.07. What do you get? 0.88. Very good. So now we can finally write our answer. Hence, 90%, no, not 90, 99% this time, right? 99% confidence interval for proportion is from 0.74 up to 0.88. 0.74 up to 0.88. So that means with 99% confidence, we can say that 74 up to 88% of the people have kids. That is the meaning of that. Now, one important thing that I want to mention here before we move forward, we have seen 3 different types of confidence interval. You really need to know the differences here. Remember, the third one, which we have just done, is the confidence interval for proportion, right? Whenever you are calculating the confidence interval for proportion, the distribution that you will be using, okay, the distribution that you'll be using is always a normal distribution, always standard normal distribution. So for proportion, always standard normal distribution. Okay, for proportion, one more time, is always standard normal distribution. But if you are working for the confidence interval for mean, okay, you want to find the confidence interval for mean, then you have to be a little careful here. You have to check whether the population standard deviation is given or not. If the population standard deviation is given, the distribution will be standard normal. Okay, if the population standard deviation is given, the distribution will be standard normal. But if the population standard deviation is not given, and you have the sample standard deviation, in that case, it is the t distribution with n-1 degrees of freedom. Make sense? You have to remember this, okay, for the mean. And we'll be carrying this concept to the next chapter also when we start working on hypothesis testing. One more time, let me talk about these two. If the population standard deviation is given, then the sampling distribution will follow standard normal distribution. Okay. If the population standard deviation is not given, the sampling distribution will follow t distribution. Okay, so we did the first example on proportion. If I go back to my slide here, you can see that we have highlighted 2 important formulas there. The first one is to find the margin of error. Second one is to find the sample size, right? We use the first formula, but we have not yet used the second formula. So in next example, we are going to learn how to use this formula and estimate the sample size. And here is this example. Okay, let's find out what's going on in this example. A political candidate has asked you to conduct a poll to determine what percent of people support her. If the candidate only wants a 5% margin of error at 90% confidence level, what is or what size of sample is needed? So here we want the sample size, right? But they have not given the proportion here. One important thing is the proportion is not given. But what they said is, we want to find the sample size to determine 90%, with 90% confidence, we should be able to say from that sample that the political candidate is supported, right? Political candidate is supported. For example, in our election in this country, for the presidential election, let's say, right, we'll have two strong contender, two strong, candidate for president, one from the Republican Party and one from Democratic Party, right? And when we say someone is getting a favorable vote, what should be the minimum amount they should get? If I say 50-50, that's equal, right? So they must get at least, one candidate has to get at least more than 50%. Does that make sense? One candidate has to get more than 50%. So we can say that the easiest number for us to pick is 51. If they get 51, if a candidate get 51 minimum, then they get the favorable vote. Make sense? So same thing here. So here our proportion P hat must be at least 51%. So that is very, very important. So here candidate asks, conduct a poll to see what percent of the people support her. When we are getting a supporting population, meaning of that is P hat must be 0.51. And what will be the Q hat then? 0.49. They should get at least above 50%, right? At least above 50%, so that they will be supported. That's why P hat is 0.51, Q hat is 0.549. Okay, we have that. And the candidates want 5% margin of error. They have given the margin of error. 5% margin of error. That means this one is margin of error is equal to 0.05, right? 5% margin of error. And we are doing all this calculation at 90% confidence level. And we need to find what is the sample size. If you remember from our previous slide, we have the formula for sample size. We can quickly use the formula and calculate the sample size. P hat multiplied to Q hat times Z critical over margin of error squared. Is that the formula? Let me go back to the slide and show you the formula again. The second formula we have boxed here. That is the formula for the sample size. And when we get the value of n, remember, n is always rounded up. Okay. So now if we try to plug in the values, look at the screen again. P hat is given here, 51.51. Q hat 0.49. Margin of error 0.05. But do we have Z critical? No. So first thing we want to do is we want to find Z critical at 90% confidence level, right? Z critical at 90% confidence level. So let's do that calculation by drawing the normal distribution. Okay, this is the standard normal distribution, mean 0, standard deviation 1, Z values along the x-axis. You know, this is a standard normal distribution. because in the formula we have Z critical. That's one way of thinking, right? If you know the formula. The other way is we are talking about proportion. And when we have proportion, it is always standard normal distribution. Okay, so we draw the standard normal distribution. Now, because we want the political candidate to be supported. When we are talking about the candidate to be supported, we want what percent should be the minimum, right? So that's how it is proportion. Make sense? Okay, good. Now let's show that 90% area in the middle. Okay, 90% area in the middle, which is this one, 0.90. And remaining 10% is divided on two parts or on two tells. So that means what percent each? 5% each, 0.05, 0.05. And the value that I'm showing here with the dot, that is your Z critical. And let's find that Z critical. Z critical, because we want to find the value along the x-axis, we'll use the inverse normal. Inverse normal. We need the area to the left. And if you look at the diagram here, you can see area to the right is 5%. That means area to the left must be 95%, right? 90% plus 5%, 95%, 0.95. 0.95. And then the mean is 0, standard deviation is 1. And you can quickly type that in your calculator to find the Z critical. Everybody type in your calculator, find the value of Z critical. 1.6449, that is correct. 1.6449. Make sure all of you type it and check it. I'll be waiting here for 30 more seconds. So all of you are done typing it. Do we get it? Oh, you're looking at the final answer. It should be a little bit different from that. Yeah. Mm-hmm. Type it again. Okay, now let's plug in the value and then try to calculate that n. So let's all plug in the value here. P hat is 0.51. Q hat is 0.49, then times, and you put the parenthesis. Z critical, we got 1.6449 over margin of error 0.05. Close the parenthesis and square it. Please type that, round it up, and tell me what you'll get. Remember, when you type it, make sure you put that parenthesis, type 1.6449 over 0.05 inside the parenthesis, then close the parenthesis and hence square it. 271. Okay. 271. Make sure all of you type it, check it, verify that 271 is correct. Your calculator is not giving. Okay. Hold on. You just do this. 0.51 times 0.49, right? Times, begin the parenthesis, 1.6449, right? Then over 0.05, close it, square it.
See, when I did that, what is it called to put error on the,
I don't know what you did, and you can try again. Yeah.
I'll show you.
Yeah, you can type it. I can see. No, don't go there. Don't go up there. I want you to retype it. Let's see. Okay, type it. 0.51 times 0.49. No. You have to put the multiplication sign times
Oh,
and
that's
then
what
the
I see.
parenthesis. Okay, yeah. Because it will not understand what you're doing if you don't put the parenthesis. Close it, square it, enter it. There you go. Yeah. So you got 270 point something, right? But we round it up, so that is 271, right? So you must at least ask 271 people to get that confidence interval of 90%. Make sense? Okay. We'll look at one more example, which is just playing around with the confidence interval. So before we move on to the last example, are there any questions on this one? Example 5 here? No? Okay. Here we go. So this one is saying, express the confidence interval. You can see that they have given the confidence interval inside the parenthesis, right? We have to change that parenthesis to plus or minus form. That is the meaning. Because we have already seen that we can write the confidence interval in 3 different forms, right? But here we have to write, or we have to change the confidence interval, which is given in the form of parenthesis, to plus or minus form. Okay. So it's not that difficult. I think this one should be the easiest one of all the examples we have done so far. So you can quickly draw the confidence interval with the information given. So we'll have P hat in the middle because it is talking about the proportion. And they have given everything in terms of percentage. So this one, the lower boundary they have given is 19.2, which is P hat minus margin of error. They have given in percentage. And upper boundary will be P hat plus margin of error, that is given as 33.8. So that is the information given, okay? That is the information given. So what we don't have is, we just have the lower boundary and upper boundary. We don't know what is there in the middle, right? What is that P hat? And we also don't know what is margin of error. How much you are subtracting or how much you are adding, we don't know that. Now tell me how we can find the value that goes in the middle, how we can find that P hat. Any idea how we find that? Tell me if you know how to find it. Say that again. Who is saying it? Yes, we want to find the value in the middle. So what we can do? So if we subtract the smaller one from the bigger one, we get the whole distance, not the value in the middle, right? Right? Add these two and then divide it by 2, right? So add the lower and upper boundary and divide it by 2. So we get the value in the middle, right? Yeah. So let's do that. 19.2 plus 33.8 divided by 2, which is equal to 53 divided by 2, and that is equal to 26.5%, right? Make sure you check that. 19.2 plus 33.8, which is 53, divide that by 2, you get 26.5. So you should know what we are getting. So we want to write our answer in that form, P hat plus or minus margin of error. That's what we are trying to do, right? We want to write our answer in that form. And we got P hat. P hat is 26.5. And I need plus or minus and then the margin of error. See, we got this P hat here. So I wrote that. But next thing I want is the margin of error. And you know what is margin of error. If you look at the diagram here, from the point estimate in the middle, We add the margin of error to get the upper boundary. We subtract the margin of error to get the lower boundary. So how do we get the margin of error then? 33 minus 8 minus 33.8 minus 26.5 or 26.5 minus 19.2. Either way, you get the same value. So let's do that. Margin of error. Margin of error is equal to 33.8 minus 26.5. That is equal to, did you say 7.3? Okay, 7.3%. That means it is 26.5 plus or minus 7.3. These are all in percentage. So that will be my final answer. So we easily change the confidence interval, which was given using the parenthesis, to a plus or minus form, right? To change into plus or minus form, you must find the value that goes in the middle, and also you have to find the margin of error. And one important thing in this one, it's kind of interesting. We have completed 7th module by completing this example, right? We have completed 7th module by completing this example. Probably you have not seen the question in the mastery exercise, which are exactly similar to the questions from the note catcher, right? But this time in module 7, there are a couple of questions which are similar to the example that we have covered here in the class. Okay. So that is the end of the lecture here.